In part B, we've got a polynomial, cubic polynomial, and we're going to start by making our list of p's and q's. So your p's are, we're looking at factors of the constant, the last number in the polynomial. So we're looking for factors of 6, which would be 1, 2, 3, and 6. And on the bottom, we're looking at our factors of q, which would be 2, which would be 1 and 2, plus or minus for all of that. Now we need to actually divide those because there's more than a 1 on the bottom. So I've got 1 over 1, which is 1, 1 over 2, which is 1/2, 2 over 1, or 2, 2 over 2, which is 1, and we already have it in the list, so we don't need to put it again. 3 over 1, which is 3. 3 over 2, 3/2. 6 over 1, and 6 over 2, which is 3, and we already have that. So we've got 1, 2, 3, 4, 5, 6, 12 possibilities of roots, and we need to test them using synthetic division to figure out what gives us remainder 0 and what doesn't. Let's test -1. Let's test -1. So if I plug in -1 to synthetic division, I'm going to put that on the outside and put the leading coefficients in front. So I've got 2, and then 11, and then -7, and then -6. We bring down our first number. Bring down the first number, and then we get 2, and we multiply that by the outside number. We get -2. Then add your column together. We get 9. Then multiply 9 by the outside, you get -9. Add the column together, you get -16. Multiply that together, you get 16. Add the column, and you're not going to get remainder 0. So -1 did not work. I don't know why it keeps going blurry, I'm sorry. Then we're going to pick another number then. So let's try +1. We put our coefficients from the polynomial on the top row. Then we bring down the 2, multiply the 2 by 1, add your column together, multiply 13 times 1, add your column together, multiply that by 1, and then when you add, we get remainder 0. So that means 1 is a root. 1 is a 0 for the polynomial. Let's try some more numbers. So what we have then is all these possibilities. Let's try something that I know is going to work. Let's try -6. Since I already have 1 working and I got it down to this, now I can take all the other numbers I try from the answer I just got. And we're going to try taking -6 out of that. So 2 comes down, you multiply, add your column together, multiply, and you get remainder 0. And so what we're left with is a linear function. We're left with a remainder, a constant, and an x. So what we're left with is 2x plus 1 equals 0. And we're going to subtract 1 to the other side, divide by 2. So -1/2 is our third 0. So we've got then 3 zeros. We've got +1 from this synthetic division, -6 from that synthetic division, and then -1/2 from whatever was left over. So those are the zeros. And just to get an idea as to what happened in the polynomial, so it's crossing at -6, it's crossing at -1/2, and it's crossing at 1. And it is a positive cubic function because 2 is positive. So it's like the last one where it's doing something like this. Crossing at those numbers, going up, down, up. If we look at C, my leading coefficient is a 1, and my constant is a 36. So as we make our P's and Q's, we've got The factors of p are the factors of 36. So that would be 1 and 2 and 3 and 4 and 6. And then we've got factors of 1 on the bottom, which are 1. And so that means if we divide all those by 1, they're going to be the same things that I have on top. Okay, so those are the possibilities that we're going to test using synthetic division. Sorry for the blurriness. All right, so we're going to test some numbers. Let's test -3. We're going to test -3. Why am I starting with -3? Because I know it's going to work. How do I know it's going to work? I've already done the problem. So what we'll do is I'll show you ways where you can figure out the first one to start with. If not, I'll tell you which one to start with. That way it's not a shot in the dark. But let's look at the polynomial. I've got a 1 in front of the x to the 4th, no x cubed, so 0, a -13 for the x squared. I've got no x value, so 0, and then our constant 36. We bring down 1, we multiply, add the column, multiply, and you get 9. Add the column, you get -4. Multiply, you get 12. Add the column, you get 12. Multiply, and you get -36. We got remainder 0. So -3 is a root. It works. So let's take out something else. I also know -2 will go in, so I'm going to go with that one now. And I'm going to take it from the answer. So we bring down 1. We multiply. Add the column, you get -5. Multiply, and you get 10. Add the column, you get 6. And then multiply, we get -12, which is remainder 0. And you can either keep going, or you can take what you have left and solve it. So I could keep going, but instead I'm going to show you how to stop here and solve what you've got left. If you can get it down to 3 numbers, then you've got a quadratic. 6 is your constant. It always goes backwards from the remainder. 6 is the constant, 5 is the x, 1 is the x squared. So we're left with x squared minus 5x plus 6, which we can factor. And so we're looking for numbers that multiply to make 6 and add up to 5, or add up to -5. So that would be x minus 3 times x minus 2. And if I set these equal to 0, this gives me +3, and this gives me +2. So that means I've got 4 answers. I've got -3, -2, +2, and +3. And notice it was x to the 4th, and we got 4 answers. So whatever your exponent is, you can have up to that many zeros. And if we look at a graph as to what we just figured out, we know it's a positive x to the 4th function, so it's going to make that W shape. And so we're assuming it's doing something like this, where it's going down through -3, up through -2, down through 2, and up through 3. D, we're going to start by making our list of P's and Q's. So we've got factors of 6 on top. And then we've got factors of 1 on the bottom. And so we just end up getting whatever was on top because we're dividing by 1 and -1. So those are our possibilities. And then we test them. So let's test something I know works so that we don't waste our time. Let's test -3. So I start with my coefficients, 1, 2, -5, -6. We bring down the first number, multiply by the outside number, add the column, multiply, add the column, multiply, and we get remainder 0. We knew it was going to work, so that's great. We then can factor what we've got left, or we can continue to test numbers and bring them out. It's up to you. Let's go ahead and factor it. Let's do that. So I've got x squared minus x minus 2. That is what's left. And so we're looking for numbers that will multiply to make negative 2, but will add up to negative 1. So that would be x minus 2 and x plus 1. And if you set them equal to 0, we get 2 and we get negative 1. And so we've got 3 solutions. We've got 2, negative 1, and negative 3. And it was an x cubed function, so it's appropriate that we ended up getting 3 answers. So we've got negative 3, negative 1, and 2. And if we were to look at a sketch of that, since it's a positive cubic function, then we are assuming it looks something like that, where it's going through negative 3. Let's pretend like it's going through negative 3 there.